Example on motion on a one dimension. A youngster throws a rock from a bridge into the river 50 meters below. The rock has a speed of 15 meters per second when it leaves the youngster's hand. Calculate the velocity of the rock when it strikes the water. If letter A, it is thrown straight upward initially. Letter B, it is thrown downward initially. Based on the problem we are given the following information starts with an initial velocity. So initial velocity is non-zero and it has two different scenarios. First, it is thrown vertically upward, so for scenario its initial velocity is positive 15 meters per second. For scenario B it is thrown downward, so it is negative 15 meters per second. The acceleration is still g equals negative 9.8 meters per second square. Based on the figure it falls at a certain height set as origin, so we set the time t0 equal to 0 and initial position y0 equal to 0. Times are not given. So we have the following parameters. v0 equals negative or positive 15 meters per second depending on which scenario, t0 equals 0, y0 equals 0, y equals negative 50 meters, g equals negative 9.8 meters per second square. Let's recall the table of equation of motions for motion along the vertical, or for simplicity let's call it y-axis in terms of the Cartesian coordinate system. We then compare it to the given values we have extracted directly and indirectly from the problem. Recall that we are asked to find the velocity depending on the scenario. We see that equations containing the time quantity would not be a good fit since we do not have the time at such given position where it lands on water. We see that the fourth equation would fit the problem. We then solve using the ideal equation we obtained in step 2. Rearranging the equation to solve for the unknown. We then substitute the known values obtained in step 1. Upon solving we get two values for the final velocity as it reaches the water below the bridge, which is negative 50 meters. Logically, we will choose the negative value since it is falling downwards. Another information that we get that either it is initially thrown upward or downward as it hits the water below both scenario tells us that it will have the same final velocity when it reaches a position y equals negative 50 meters. So for letter A, it is thrown straight upward initially, and letter B, it is thrown downward initially, will have the same value of final velocity. Remember to show your solutions systematically and box your final answers. The end for now. For questions and comments you may send them to diyeslearningstuff@gmail.com. You may review the slide on YouTube at @dies learningstuff. Note, please do not forget to use your school email. Also write your complete name and class section. Thank you for listening and see you next meeting.